tutorial on mixtures. Mixtures is one of the three main classes of matter. We have we have compounds, we have elements, and we have mixtures. When it comes to mixtures, there is some terminology that needs to get explained so that everybody understands when we say things what we're talking about. The first types of terms we're going to throw out at you are the two main categories of mixtures. There are homogeneous mixtures and there are heterogeneous mixtures. Homogeneous mixtures are made up of particles that are so small that they have uniform composition. What that means is that if I were to look at it, it would appear to be one substance. And I would not be able to see the individual pieces of the mixture unless I had some type of experiment going on where I'm able to isolate those things. A heterogeneous mixture is the opposite. I am able to see the pieces of it, therefore they say it does not have uniform composition. You'll learn that each of these types of mixtures will have its own sort of subclass, right? But they're all based around the same idea, that I take one substance and in some way or another I dissolve it or mix it with another. So that leads us to a different series of terms. Anytime we are mixing different things together, we will describe them as either being soluble or insoluble. Insoluble is just a fancy word for dissolvable. So if something is soluble in something else, that means it is able to be dissolved in that substance. If we're talking about solubility, there are different components of a soluble substance. One of them is called the solute. One of them is called the solvent. The solute is the thing that gets dissolved. Therefore, the solvent is the thing that does the dissolving. Water is known as the universal solvent, right? Because water has the ability to break down and dissolve many, many, many substances, ionic or covalent. So if something is soluble, it's dissolvable. If something gets dissolved, it is the solute. If something does the dissolving, it is the solvent. That'll lead us into one of our three classes of mixtures that we're going to talk about. The resulting solute-solvent interaction leads us to a solution. And a solution is one of the three major categories of mixtures. In class, I use different sides of the room to help distinguish between these. But for the purposes of the video, we'll have to do it all on this one board. The three major categories of mixtures are suspensions, colloids, and solutions. Each of these things has their own particular characteristics. Some of them are very similar to each other, some of them are distinctly different as we go through and look at them. The easiest to identify of the three are suspensions. There's a few reasons why. First characteristic of a suspension is that they are heterogeneous. You are able to see the pieces of the mixture, right, when you are mixing them up. Second characteristic of a suspension is that it has the largest particle size. If we were going to quantify that amount, we would say that it's over 1,000 nanometers in particle size. And although a nanometer is very small, 1 times 10 to the negative 9th, in terms of being a particle size, that would be far too large for it to be able to be held in a different substance. Third characteristic of suspensions is that they can be filtered. If I were to take an example of a suspension, for instance, something like a glass full of marbles with water in it, and I were to stir those, it would appear that it were all mixed up in a moment's time, right? But if I were to pour that through some sort of filter paper, the marbles would stay behind and the water would go through. Similarly, suspensions separate while standing. What I mean by that is the same example I gave you a moment ago. If I were to take water and marbles and stir it up, it would look like it were one thing for a moment. But as soon as I were to stop stirring it and allow it to stand, the marbles would fall to the bottom and the water would stay atop and then a little bit within, but the marbles would separate out of the suspension while it were standing. That, coupled with being filtered, make suspensions the easiest of them to identify. If I were to show you an example of something that were a suspension, I would bring out something we used earlier this year, which was this mixture of oil, glycerin, water, and alcohol that layered itself. And the reason it layers itself is because these substances are insoluble. They do not dissolve in each other. The idea behind this being a suspension is it fits some of our characteristics. If we take a look, is it heterogeneous? What that means is, can I see the pieces? You bet. I see a clear piece, I see a purple piece, I see an opaque piece, I see a green piece. Does it have the largest particle size? That's one of the things you can't really tell simply by looking at it with the naked eye. Can it be filtered? If I were to pour this substance through a filter paper, you would find that the alcohol would pour through, but the cooking oil would get caught behind. Does it separate while standing? Absolutely. These things are layered up because they will pull themselves apart while standing. So here's a good example of something that would be a suspension. And we will go through many, many other examples throughout the course of this, but that is the first, and we'll leave it over there. Second category of mixtures that we're going to look at are colloids. And colloids are homogeneous. They have uniform composition. They have medium-sized particles. If we were to quantify that, it would be between 1.0 and 1,000 nanometers in size. Colloids cannot be filtered, and colloids do not separate while standing. Now, it's easiest to talk about colloids in solutions before we show examples, and you'll see why in a moment. But our categories of solutions, characteristics, are that they are also homogeneous. They have very small particles. Again, to quantify it, I would say that their particle size is between 0.01 and 1.0 nanometers. Solutions cannot be filtered, nor will solutions separate while standing. So if we do a side-by-side comparison of these three substances, what you will see is two of them are very, very similar, and one of them is distinctly different from that of the others. If we look at it a line at a time, suspensions are heterogeneous, colloids and solutions are homogeneous. Suspensions have the largest particle size, colloids medium-sized particles, solutions smallest particles. Suspensions can be filtered, colloids and solutions cannot be filtered. Suspensions will separate while standing, colloids do not separate while standing, and solutions do not separate while standing. So if you notice, suspensions are the uniquely different ones, which makes them the easiest to identify as we go through. Colloids and solutions, however, are very, very similar. Neither separate while standing, neither can be filtered, they're both homogeneous, and if we look, we would have to be able to see the particle size to decide if a substance that I were looking at were a solution or a colloid. That is something that's impossible to do with the naked eye. So what we have to do is we have to have a different way of telling if something is a solution or a colloid. And that is something that we refer to as the Tyndall effect. Tyndall effect. It is a way of classifying the difference between colloids and solutions. Okay? The Tyndall effect says that some substances have the ability to scatter light while others do not. As it works out, we have learned that solutions do not scatter light. We have learned that colloids scatter. Now, what does that mean, scatter light? Well, what it means is, if I were to take this laser pointer, for instance, and I were to shine it on the board, you can see the red dot that's on the board, the resulting effect, but you don't get to see the laser beam that is running through the air between the tip of the laser pointer and the whiteboard. The reason being is that clean air, unpolluted air, is a solution. The light does not get scattered, and then it hits its target. If we were to take it with something that does scatter light, a colloid, we should be able to see the laser. And the best example I could give you is if I were to bring two different beakers up here. And with these beakers, one of them is a solution and one of them is a colloid. And so if we were to test it by putting the laser pointer next to it, I could take my substance and show you that I haven't done anything to these. Okay, this one here, I could have a laser beam right next to it, and if you look at it, and if I were to shake this up a bit, you will see that the laser beam will show up in the colloid, which we will say, because I can see the beam going through it. Notice it does the same with this substance. So if we put them together to get us a little bit of a larger sample size, you can see that the laser beam will show up as we go through the colloid suspension. And if this were a simple solution, it would go straight through. So if we were to look at that, just with regular light, that now gives us a way to tell the difference between colloids and solutions. And what you will find is that colloids, because they scatter light, tend to be cloudy, whereas solutions do not scatter light, they tend to be clear. So that is how we will tell the difference between colloids and solutions. Your solutions tend to be clear. Be careful. Clear does not mean that they don't have color. I could have a blue solution, for instance, but I'm able to see directly through it, which would make it be a solution because it doesn't scatter light. I could have something that is colorless, like this, but it is cloudy and it does scatter light. So what I like to do is start to classify a bunch of different substances into one of our three categories: solution, suspension, or colloid. And when we did this exercise in class, we did about 25 different ones, and I will read these note cards to you so you can see what they say, and then we'll talk about where they go and why it is that they go there. So, first one up here, it says smoke. First thing you have to decide is, does smoke look like one thing, or can I see the parts of it? So we always eliminate suspensions first. Right? As I go through, I say, can smoke be filtered? Will smoke separate while standing? Right? The answer right to that is no, which means now it's either a colloid or a solution. Right? Then, the way we just decided, if it's a colloid or a solution, is through the Tyndall effect. Right? If it is cloudy, it tends to be a colloid. And sure enough, smoke I would classify as cloudy, so it would go into the colloid. The second one is taco dip. Right? If you can see the pieces of it, or I could filter it out, right, I would say taco dip is a suspension. Sure enough, we can see the pieces of taco dip. You can see the pieces of taco, you can see the meats, you can see the cheeses. I would say that taco dip, therefore, is a suspension. Next one, Colby Jack cheese. And if you're unfamiliar with it, Colby Jack cheese is the type you get at the store that is yellow and white mixed together. And that should tell you all you need to know. Because I can see the yellow piece and the white piece, it does not look uniform. That means Colby Jack cheese is a suspension. That leads us into a little bit of a discussion. All of these characteristics were mostly for liquids. Right? How can I tell in a solid if it is a suspension or a solution? Right? If it's a solid. Generally, here's how you do it. If we are looking at a solid, it is either going to be a suspension or a solution. The reason being, you do not see a whole lot of colloidal solids. They tend to be foams and things of that nature. If it is a suspension, it's heterogeneous, I can see the pieces. If it is a solution, it looks like one thing. So with our solid substances, that is what I will use to classify them into their different categories. Okay. Next one says sandy water. Right? Sandy water, right? Can I filter that? Yes, I can. You have to go no farther. If I can filter it, that means it's a suspension. The next one says nails in water. Right? Whether it be fingernails or hammering nails, right? Nails in water can be filtered and it will separate while standing. Those both make it a suspension. The next one says tap water. And you may say, what is tap water a mixture of? Well, it has fluoride ions in it to strengthen your teeth. There's calcium. There are lots of different things in your tap water. Right? So I look at my tap water. It can't be filtered. It doesn't separate. Can't be filtered. Doesn't separate. So I have to decide, is it clear or is it cloudy? And hopefully our tap water at home is clear, which means it will be a solution. Salt water. And I have to clarify these. Like, salt water is referring to not the ocean water, but water that I took, say, a teaspoon of salt and shook it into. So if I looked at my salt water, it can't be filtered. It doesn't separate while standing. So that puts us over here. Then we say, is it clear or cloudy? And as long as there's just a little bit of salt, right, salt water will dissolve. It will be clear. It is a solution. The next one is Sprite. And if I take a look at Sprite, all right, it will not separate while standing. It cannot be filtered, right, which means it's a colloid or a solution. Sprite would be a solution because it is clear. Similarly, sugar water, which is essentially what Sprite is with carbonation. Right? Sugar water will be clear, doesn't separate while standing, therefore it is also a solution. Kool-Aid, right? Kool-Aid, I take my sugar crystals and food dye, mix them all together, it looks uniform, therefore it's homogeneous. With it being homogeneous, is it clear or is it cloudy? A lot of Kool-Aid will be colored but it is clear. I can see through it, therefore Kool-Aid is a solution. 14 karat gold. Some of you may not realize what 14 karat gold is a mixture of. 14 karat gold is a mixture of gold and silver. They put silver in it to strengthen it, right? And putting silver in it allows it to be sold more cheaply, right? So that people can use it. So the question becomes, because it's a solid, does it look like one thing or can I see the pieces? Right? Well, I cannot see the pieces. It looks like one thing. Therefore, 14 karat gold will be a solution. Next one says oxygen. Right? Oxygen is an element. Any element or pure compound, right, are only made up of molecules or atoms of that element. Right? So it therefore must be a solution. All elements and compounds are solutions. Next one says air. Right? Air, we've decided, right, has a couple characteristics. Clean air or polluted air. This refers to clean air. Right? Clean air will not disperse light, therefore it is a solution. Nitrogen is the next one. Nitrogen is an element, therefore it is a solution. Right? Shaving cream. Right? Shaving cream is the next one. Right? Shaving cream is a mixture of a liquid and a gas, therefore making it foamy. Right? Right? Because it's foamy, right, it cannot be filtered because it could go through a filter. And is it clear or cloudy? I would say it's cloudy. Shaving cream is a colloid. Right? Paint. Paint has to be one that we describe. If it's an oil-based paint, right, an oil-based paint will separate while standing, it would be a suspension. If it's a latex-based paint, water-based paint, right, they do not tend to separate while standing. So we'll say it's an oil-based paint, therefore it's a suspension. Okay, next one, fog. Okay, fog does not separate while standing. It cannot be filtered, therefore it's a colloid or a solution. Right, and we ask, is fog clear or cloudy? Fog would be cloudy, therefore it is a colloid. Clouds. Clouds don't separate while standing, therefore they're not suspensions. Are clouds cloudy? I sure hope so. Therefore, a cloud is a colloid. 2% milk. Right? 2% milk, right, is a substance that does not separate while standing. I cannot filter the 2% fat out of the milk. Therefore, it's either a colloid or a solution. Right? What you will find is that it is a colloid, right, because, right, it is cloudy. The light does not pass straight through. Right? Next one we have is smog. Right? Smog is something that does not separate while standing. It cannot be filtered. Smog is cloudy, therefore it is a colloid. Right? Brass. Right? Brass is a solid. Right? So we're going to come over to here. Right? We have to ask ourselves, does brass look like one thing, or can I see the pieces of it? I think brass looks like one thing. Right? Therefore, brass would be a solution. Very similarly, steel. Right? Steel is a solid. Right? Do I see the pieces of it, or does it look like one thing? Steel looks like one thing, therefore it is a solution. Right? Second to last one we'll take a look at, right, is a salad, a Caesar salad. Right? If you think about a Caesar salad, it is a solid. Can I see the pieces of it, or does it look like one thing? I can see the pieces. I see the tomatoes. I see the lettuce. I see, right, the different parts. Therefore, a Caesar salad would be a suspension. Right? Last but not least, right, the last one here, right, is just plain old-fashioned, right, food coloring. Right? Food coloring in water. Right? Food coloring in water does not be filtered, or cannot be filtered, and does not separate. Right? Is it clear or is it cloudy? It will be clear, therefore it will be a solution. So you get suspensions, colloid solutions are our three categories of mixtures. I hope this has helped refresh your memory on how to classify those different things, all right, so that we can push on for the future.